I'll roll with it.
Hi guys, welcome. There are still a lot of places here in the front, so I would actually like everybody to move a little bit closer so they don't have to scream. Well, they got mics like me, but it gets a little bit more cozy if you actually move here a little bit closer to the stage.
We don't bite, we don't throw things.
Well,
okay, not much, but
I can throw this.
Yeah, the freebies. You shouldn't have hardware as freebies. People are not really paying attention. There, that looks a lot better. I actually have to cheat a little bit because I got this a couple of minutes ago, being moderator here. So, G4 self-powering global sensor net for IoT. Sounds interesting. Let's hand over to the guys who actually know these things. Mark Heckler and Jose Pereira.
Thank you very much.
hello. We'll start off, I guess, with a brief introduction. Kind of the plan of the day. We have a lot of material. We don't want to just blast it out there, but we want to try to cover everything. Answer any questions. If you have a question throughout, say something, raise your hand, whatever. It's kind of hard to see sometimes in the back, so just shout out something. We hope to have plenty of time for questions and answers and exchanges at the end, but if we sneak some in throughout, that's good too. So first we'll start off with Jose.
Okay, you can present me.
Oh, okay. My colleague is Dr. Jose Pereira from the University of Valladolid in Spain. We met, I guess to give a little bit of background, we kind of met from opposite ends of the spectrum. Jose was working with large renewable energy systems and connectivity in that regard. I was kind of looking at it from a small hobbyist perspective and building up. And the more we talked, the more we exchanged information, the better it got and the more ideas kind of bubbled up. Jose has an excellent blog. I encourage you all to check it out because he does a really nice job of documenting things from start to finish at a very introductory level all the way to the advanced within a couple of 3 blog posts. And you can get a lot of good information from that. Please follow him on Twitter at jpereidadnr. Great material there too.
Okay, thank you, Mark. You are too kind always. So Mark Heckler, he's from the US and he's a Java software architect or engineer working in Oracle. And we met, as he says, in this common space we are talking about here, which is the IoT or the embedded space. And since a few months, we've been working together. Before we had a session in Java 1, a tutorial, talking about embedded stuff. And since then, we've been working with this session from here because it's more or less the same, and we will deal with this throughout the session. So please follow Mark also in his Twitter handle, his blogs, and he has really great content also there. And we would like you to, throughout the session, to get a glance of what we do. You will see that we don't do a special thing. We don't do any magic. We just play with toys at home. These are toys, but in fact they are not toys. So we will like you to join us in this session and see what we can do. And for sure, as a first notice, we would like you to forgive us if we have something not good or something failing, because this is actual coding and slides. This is actual feedback from our devices. The devices we are going to use, these are not the ones we are using. These are just for showing you. The actual devices are at home. So we will cross our fingers because maybe they can fail. So if they fail, for now we apologize, but we say, okay, this is what we do. We play, most of the time we fail. So if you get success from the beginning every time, it's not interesting. The real deal is, okay, play, fail, try to do it again. Maybe you can succeed at the end. So we'll see what's coming after that.
Yeah, James Gosling once said that if you're not failing, you're not doing enough. And, we're kind of pressing against the edges because the embedded space has been there for a long time, but it's really starting to kind of take off now, and you're seeing a lot of activity in a lot of different directions. So we press against the edges. We try to find out what works, what doesn't. We chase a trail until it dead ends, and then we chase a different trail. And we found an awful lot of really cool stuff by just exploring. So we're all just kind of exploring together, maybe different paths, but that's why we're here to share and learn more and grow as a group. So, okay, kind of a summary of the things we want to hit today. First, to address the need for remote monitoring. What can it be used for? What is it good for? Why would you even do it in the first place? Some of the requirements for embedded systems at different levels of scale. One approach, we're not saying our approach is the only approach, it's definitely not, but it's an approach that we've developed and honed over time, and it seems to work pretty well for us. Discussing the software, the hardware, and the power requirements, as well as the power that's involved, and we'll get a little into that more later, the renewable energy projects. How to build it, so you'll get at least a taste of how to start from nothing and build into a real working system that has a lot of usefulness, and try to address any questions you may have. Okay. First, where would you use remote monitoring? Well, pretty much anywhere. And once you kind of put up your antenna, you'll see different opportunities, maybe at your level, at a corporate level, in public and private institutions. But we've just named a few here. Different retail locations. Pretty much every major retailer has remote communication and monitoring going on all the time. Industrial settings, of course, and they've been the pioneers a lot of times from way back. And energy production, you're seeing that become, it's kind of a turbulent world in renewables right now, but that's something that is very important to keep track of and monitor and actively manage as best you can. Of course, security mechanisms, and Jose has done a really large implementation with this, with barriers and gates, different panels for feedback and control, different signals, audio signals, visual signals that give you a control panel or an overarching control set, so you can monitor and manage things from a good distance. And we actually have some good examples of that, as Jose mentioned. We wanted to set up a global network that can talk to the different nodes, and so far that's mostly worked from here. So. And continuing, sensors. Jose has also worked with a monitoring system. I keep using you as an example. I hope you don't mind.
Sure.
But atmospheric sensors, very important. And David had mentioned in the keynote this morning, the standard thing that people a lot of times start with for atmospheric is temperature and humidity. And that's something at a very local level that has meaning, as well as a global level. I mean, if you turn on the weather in the morning, a lot of times you're very interested in your local weather, but you also are kind of curious where you may be traveling or where your family may be. So anything that can be monitored or managed is a good candidate for an embedded solution.
So these components we try to use in an industrial environment. Okay, thank you. Sorry. These components, you can try to use them in industrial environments. They are expensive and they are quite complex. You have to take care of many things to deploy these components. But we are going to turn this into a home system where everything should be more easy to use. We should have a few components, and we should be able to do it fast and reliable and a way, and you should have an easy to install and configure, to set up everything, to test it. And for sure we are looking for some devices with minimal footprint in the physical way and in the logical way. So we need to find devices that are easy to use, inexpensive, with minimal draw forward. Go ahead. And once you have these devices, the other thing that comes with them is communications. So we also need a communication system and many different protocols, because any device have, all of the devices have different protocols. So you need mechanisms to support this communication between all the devices, so everything is connected. And at the end, you need also that these devices have a connection which you can rely on. So you can go, like we are going to show, you go 3 days out of home and you're still connected, and you can get a connection straight outside your home and it doesn't break.
Okay. One of the things that we like to stress is that, especially when you're looking at the embedded space, if you come from large systems, is that you adjust your expectations regarding performance. Performance will never be the same on a small embedded device as it is on a massive fire-breathing server. But system performance should be sufficient. So what are your expectations for data retrieval? What are your expectations, again, as I mentioned, connectivity. How much data are you going to be passing back and forth across the pipe? What kind of frequency are you going to be looking at? The control level you need. The performance should be sufficient. It shouldn't necessarily be impressive, but it should be perfectly adequate for your needs, as well as have a little bit of buffer, obviously, for growth. Various criteria involve different modes of communication. Again, the amount of data you're passing back and forth, ways to minimize that data, ways to tune for performance to keep that performance high, and, well, again, tunable. And in most situations, small wins. We were bouncing ideas back and forth about different things that in the past you would have to deploy a full server for. Now you may be able to deploy a Raspberry Pi. Not all cases, but that really takes the cost of standing up new initiatives, large or small oftentimes, down to sub $100, 100 euros. It's not very expensive anymore to deploy at least a starter solution. And sometimes that is more than adequate for several months, years of growth. And in many cases, you can deploy that. It has low power. I don't want to get ahead of myself too much, but low power requirements, excellent connectivity, and it's just really inexpensive to do. You should have full functionality from a very basic configuration. That doesn't mean you'll stay there, but you should be able to deploy an immediately useful solution without a whole lot of pieces, without a whole lot of expense. You should also be able to add components. It should be modular enough that you can plug things in, and without a lot of heartache, be able to get those spun up and running. And if the system does need to grow exponentially, you should be able to either upgrade or migrate very easily.
So the thing with this Internet of Things stuff, with all the devices that are coming out to the market, is that we are on the very beginning, and this is a very young area for having standards fully tested, and everything just is not right there. So we need to find the way to make this looking into ways to have this everything standardized, and we think we are not there yet, but everything will come out, and all the devices should be talking in a way that everything could be connected easily. One other thing that we have to deal with is, as I said before, you are going out of your home, you are going out of your router, and you need to access these devices. So you need to figure out a way to get into the device, log in, and check easily if it's running, if it's not, reboot it again, or start another process or whatever. And you have to do it for sure with security, and you have to take care of many things. I would like to share an experience I had with these things, because as I said, I was at home with my Raspberry Pi, and I have to open the port to get SSH or BNC access. So I did open the port in my router, and the next day I couldn't access my Raspberry Pi through BNC, because there were two bots out there trying to get into, and because the many times the server block me even the access to that way. So these things also matter. You have to take care. You have to gain access, but you have to do it in a secure way. Okay.
And just to give you a little bit of an idea of how our systems are set up.
We will come out later.
Yeah, that's good. On the left is my system that I have built out. I have a utility shed, and I have a small renewable energy system set up. 3 solar panels, a small wind turbine. I wanted a way to monitor that energy production off of that. I also wanted a way to manage that, so I didn't have to traipse out there and do anything and hook up things and check dials and gauges and stuff out in the shed. And that's one thing that we kept coming back to, is that many times utility installations, or, well, anything you would use, some embedded systems a lot of times, are not immediately accessible. They're not right next to you. You have to go somewhere, or you have to be able to virtually go somewhere to retrieve the information and make that useful. So what I have set up, a small energy production system, some battery storage, several batteries making up a storage array of energy. The systems that are monitoring that are powered by that. So it's kind of the self-licking ice cream cone, a closed loop. They monitor the system and the energy production. They also are powered by the same systems they're monitoring. And what I basically have is an Arduino, and we'll get into some of the reasonings behind that as well. Arduino, as Jose has, and multiple sensors.
Just one thing,
sure.
Mark, please. I guess you all know about Arduino and Raspberry Pi, but I would like to know for sure. Do you know the Arduino? And do you have Arduino at home? How many of you have Arduino at home? Okay, so you have Arduino for sure. You will have Raspberry Pis also? Yes? Okay, great. Go ahead, please.
They each have their strengths, and I think I have a slide in here in a little while that indicates why Arduino, because every platform has its advantages and disadvantages. But we use the Arduinos to drive the sensors or retrieve data from the sensors. And then we have a Raspberry Pi running Java, which collects, kind of serves as our remote node concentrator, and then radios the information, the data, back into the server, which is also on a Raspberry Pi. If you scroll up a little bit. And then we wanted interfaces that we can use to monitor and manage, which we have HTML5, JavaScript, as well as JavaFX client that we use to do that. And of course, everything is tied together with RESTful web services and WebSocket, so it's very interactive.
Okay, I have more or less the same deployment at home. I don't use batteries, or I have also a photovoltaic installation at home, but it's just a big installation. It's not for these things. So I just put a lamp there and a LED, and I connected this to an Arduino and use XB, which are these antennas. So I wirelessly connect my Arduino to my Raspberry Pi and send the data every 2 seconds, 6 seconds, 10 seconds, whatever. So the Arduino connects wirelessly, as I said, to the Raspberry Pi. And the Raspberry Pi acts as a gateway to connect to the server, which is in another Raspberry Pi. And as Mark says, we have WebSockets connection. So there is, in any of our server, we have a WebSocket server, but we can connect with each other, so we can cross data, and we are actually doing that. So every data my Arduino is getting, it's sending just to my server, and my server broadcasts this data to whatever client, and one of these clients is also Mark's servers, and the other way around. He also is sending his data to my server. Okay, so
Next? Yeah, we'll go ahead.
How we did that, and we will tell how we can use for this thing. We can use Java to deploy not only the server but also the remote gateways, Raspberry Pis, and even the rich clients we are using. We have, as we said, we have Arduino in the backend. So for us, Arduino is the very, very reliable equipment. We have an expensive equipment, so we can use it just to plug any sensor we want. And we can plug relays, so we can control real things, not only LEDs. We can control a lamp, a heating system, whatever. So though it's at the back end, it's the very part we are relying on. So without the Arduino, we couldn't do the rest of the things. Then we need to get everything talking to each other. So for that, we use mainly WebSockets. So every device has an API where you can connect with WebSockets. You have a client or a server endpoint, and everything talks flawlessly, seamlessly. You don't get any delay. Everything is just out of the box or ready to go. We use also REST services because we have a persistence system to put all the data in our servers to store all the data. And we also have our clients, and we use HTML5 and JavaScript for browsers and JavaFX for desktop.
Okay. One announcement that was made at last year's Java 1 that was really nice is that all builds of Raspbian will include Java SE Embedded from here on out. Raspbian has always readily supported Java, but it also, and a lot of people don't think about this because they still have the misconception that Java Enterprise Edition is big and heavy and bloated and slow. That couldn't be further from the truth. And one of the things that we did was employ Glassfish Web Profile, Glassfish 4 I should say, Web Profile, to get everything we needed from Java EE on a Raspberry Pi. And performance, we really didn't expect much. When I put that on there initially, I was expecting really bad things to happen. But it's very good. It's very performant, very responsive. The Raspberry Pi, as you all know, is very compact, so you can deploy it pretty much anywhere. You just need a very small piece of real estate to stick it in and kind of forget about it. It's very inexpensive, and you can get them pretty much anywhere. And the Arduino. Why would you use Arduino? There are a lot of other choices out there. Well, there are excellent reasons to stay with an Arduino for what the capacity we're using it. First of all, shields. You can get a shield, which is an add-on component board to do pretty much anything. Sensors. A lot of libraries are out there already written, open source. The community is phenomenal about sharing information, sharing code. The hardware itself is open source, so if you think you have a better way to build an Arduino, you can do that. That option is open to you. One thing that really we absolutely love for renewable energy systems is the Arduino just barely even sips power. The Raspberry Pi certainly isn't a big power drain, but compared to the Arduino it is. The Arduino takes very little power at all to keep it running. And it also, a couple other things, input and output in regards to power. It's rated for 7 to 12 volts, but it'll actually keep running down to about 6 volts. And you can have up to 20 volts power rating coming into it, and it still handles it. It also has 3.3 volt and 5 volt outputs because different add-on components have different power requirements. Well, they're both right there on the Arduino board, or at least many different Arduino boards and licensed versions and clones.
So for comms, for communication, there are several devices also, there are several options. As Mark says before, we are talking about our approach, which is not the only one. You can do it in many other ways. But there are plenty of devices out there. You can use Wi-Fi for most of everything, but for example, for the Arduino, the Arduino just has an USB port. So maybe you need to put a seal. So there are seals with Ethernet connections, or you can find a seal with a Wi-Fi connection, or also you can use as I said before, XB, which you can put a Zigbee protocol and kind of wireless connection. So there are many things you can do to put it all together, but you have to keep in mind that everything at the end must rely on your local configuration at home. So you have to connect everything to your router, and you have to open, maybe you have to open some ports. And if you want to go outside and reach home, at the end you need also, for instance, to get a static IP so you can monitor your things outside your home. And at the end, you have to deal with many things in communications stuff also.
Now, and we've kind of covered the top part of this slide, so I'll skip right to the bottom. Low power consumption is a good thing in any system, but it's especially critical for a remote node cluster because you don't, in my case, I have a small renewable energy system, about 75 watts of solar panels and about, what is it, I guess it's about 30 to 40 watts of wind turbine power that can possibly be present at any given time. So you don't want to chew up all of your power just running the systems. So the less power you're actually consuming, the better. This is a short video I took once I initially installed the wind turbine. Behind the shed itself are the solar panels, but solar panels aren't very exciting to look at. I mean, they sit there whether the sun's out or not, so we just have the wind turbine show. Nope. There we go. Now, this kind of is the fun part. That's all setting the table, but how do we build it? How do we get there? How can you build one? Again, maybe you have a better idea and would love to hear it. This is just kind of the approach we took and wound up with after several different exploratory operations. And let's start off with kind of covering briefly what we have in place.
Sure. It's your turn.
Oh, okay.
Yes, it's your deployment.
As Jose mentioned, I mean, there's nothing really exotic here. We have an Arduino. I have an INA 219, which monitors current and voltage. And then we each have slightly different models of temperature and humidity sensors, but they're widely available, the DHT11 or DHT22. You'll probably want a solderless breadboard so you can immediately and quickly plug in and unplug and change connections.
With these jumpers. So
with jumpers.
Very easy.
And then over here to the right, you see a relay. And what that allows you to do is have a small amount of current that the Arduino can produce, switch on and off much larger, more power-hungry devices. And what we have that, or what I have, well, actually you too, we have it set up to, in my utility shed, I have a status lamp which should be on two modes, automated or non-automated, autonomous or non-autonomous. When it's running on its own, the status lamp will be on unless temperature drops to 1 degree Celsius inside, and the voltage level of the battery array is at a certain level. Then it'll kick on. The ultimate goal is a heater. Right now I have a heat lamp because it draws about a third of the energy. And again, for the proof of concept, that's sufficient. And then when those conditions are not met, then the heater kicks off, the status lamp kicks back on. We also have a way to override that so we can control it. If I have to walk the dog at night, I just flip on the light and it blasts light throughout the entire backyard and I'm good. And Jose has a really nice lamp set up on his desk that I've been switching on and off in the middle of his night to the same effect. To the same effect. So. And here's just an example of some of the code we have. You know, I don't know, well, many of you have used Arduino, but for those of you who haven't, if you're familiar with Java, the language is not dramatically different. Processing language is reminiscent of C. If you know Java, you'll immediately be able to be productive with this. The Arduino IDE is very functional, very friendly, and again, many libraries you can quickly import and get started with. So
this should be this.
Right. Basically, you have the pound includes, like imports. So you pull in the libraries that allow you to do to control or whatnot. Next. And deploying the sensors. On the left is just an example of the Arduino and the breadboard, and again at the top left is the relay and the temperature and humidity sensor, the status lamp, the INA 219 for the current and voltage. Over to the right is it in action. And then in the bottom right is kind of the whole setup. I guess let me point up here because that way it's a little easier. Over here is the Raspberry Pi with a USB hub, which the USB hub powers the Pi. The USB hub is powered by an inverter. The Arduino I actually have running directly to the batteries because it seemed to make sense. They're powered by DC, so I convert from DC to AC to DC. So I have it powered directly. I just didn't have time to get the Pi finally converted because I'd have to step down to 5 volts for that. Charge controller beneath, and then out of sight, or well, I guess you see some of the terminal blocks. But that's in effect the whole system, with the exception of a small Raspberry Pi that I have with a camera, so you can kind of watch it.
Okay. For me, it's kind of more or less the same, but I don't have the renewable system, so I just use the relay to switch on or switch off a lamp. And I have also this XB, as I said before, to communicate wirelessly to the Raspberry Pi gateway. And I use this is a board where I can plug the XB, and this is the sensor, and this is it for the back end. This is all quite inexpensive, and you can't buy it and for many stores out there. We like to use this tool to make a schematic, so it's also good for the presentation because at the end you have the schematic, you just print the image with it. But the good thing is you have everything clear from the beginning, and you can set what you're going to do. In my case, it's very simple, but you have seen Mark's case, which is a little bit more complex. So this tool helps you designing and putting things all together. This is also the part of my code, which is very easy to understand. You just need to import the libraries and use this setup to set the pins you are going to use for the lamp, for the relay. The DHT, what it does is just takes the temperature and humidity every 2 seconds. So I just get this data and send it to the serial port. The serial port is with the XB, so the XB automatically sends to the other XB in the Raspberry Pi, which also is connected in the serial port and gets the reading. Besides, we have this way of acting externally to change to automatic mode or manual mode and act on command lamps and what. So this is the display I have at home. I use this seal to plug the relay. I also use this seal to plug the XB. So beneath all of them is the Arduino, and this is the breadboard with all the jumpers. I like to keep it that ugly to show that everybody can do that, because I'm an engineer, but not in the electronic field. I'm in another field, and I don't like soldering. I don't like to do these things. But with jumpers, it's so easy. You just plug it, and you're ready to go. And as I said, keep it that way so you can teach, for instance, your kids what you are doing, and it's on my desk, so they come and go every now and then and see what is there, and they touch it. There's no risk at all, and everything is fine. So this is the lamp I have connected. You just need to cut one of the wires and put the relay in the middle. So when you act the pin, the digital pin, you let the current flows and the lamp goes on, and the other way around. And this is just a LED to get sunlight. So this is the back end, and we need this Raspberry Pi. So we can put another XB acting as a concentrator, which is the master of the nodes. For sure, this is very simple because we have only one sensor, one device only. But you can put a mess of sensor at home and put 5, 10, whatever number of Arduinos with XB or anything you want to do at your home, and use just one concentrator to get the readings from all of them. So Then in the Raspberry Pi, you need this library to get the serial readings, which is the RxTX library. You can just install it from the command line in the Raspberry Pi. And the protocol for the XB is really easy, because at the end you just get data from the serial port, so you just read it in plain English or Spanish or whatever. So there's no big deal with that. We use local login to get all the data persisted there, and then we send the data from this Raspberry Pi to our server, which is another Raspberry Pi, through WebSockets.
And I guess, yeah, that's just an example. And again, these are remote systems, so it's very important that, again, keeping it light most of the time, but you want to be able to ramp it up when you need a little more control. So typically what I do is I kind of joke about sitting in my bathrobe and bunny slippers and controlling my remote system because I can secure shell into my Raspberry Pi out in my utility shed. Fire up the desktop. X-forwarding gives me the full control sitting there to where I can update my Arduino software and push it to the Arduino and never have to get dressed and go out to the shed. So full capabilities, again, keep security in mind. I typically only run the VNC server when I absolutely need to, which means that that closes that avenue as well, but passwords and the usual disclaimers apply. So then, deploy the gateway. Once you have the Arduino in place and it's gathering the data, then you put in the remote node concentrator, if you will, the Raspberry Pi in the remote location. You make sure that it's capturing the data from the Arduino, saving it locally, and then you look to connect it with your system inside, the house, the office, whatever.
Yes. So it's, in my case, it's all together on my table, just to show it easily. And the distance between desks is so short, but you can at home you can play with long distance, just in any different rooms. There are other XB that you can use for long distance, but these are the Pro versions, are more expensive, but it's not required for this project. And this is it. We have everything we want now in one Raspberry Pi, all the data, and we can control our devices. So now we need just put the main part, which is the server, which is another Raspberry Pi, and we can put embedded versions, a small version of Java, but we said, okay, why don't we try GlassFish, the full stack? So we went to the web, pick the web profile, download it, unpack it, install it, and it works out of the box. You just need to configure your database, you just need to configure your user password, and put a service, so you can, when you put your Pi, you just need to start the server. The only drawback we have here is that it takes around 2 to 3 minutes to start the server, which is quite some time for a big device, but for a Raspberry Pi, it's not a big deal. And you just need to do it once a day, once a week, depends on what you are doing, or you just keep the Raspberry Pi on 24/7 days a week. So this is not such a big deal. We can also use a console, or we can use it on our browser. You just have to open a port for that, but it takes so long in your desktop to access the GlassFish servers in the Pi. So at the end, you just go to command line and do it all there.
And one thing I'd like to throw in there is, again, efficiency and performance. We use WebSocket for most things, and with the Java EE spec, WebSocket is included. It's a web standard. It's a Java standard. WebSocket is very performant. It's minimally framed, so instead of passing large headers of several hundred bytes with every transmission, you're passing 2 bytes with each transmission. So especially when you have small message sizes, that becomes very performant. You eliminate a lot of the overhead and a lot of the burdens you would have that would put a small platform out of contention. You all of a sudden now have something that actually really works in a lot of cases. Here we go. This is live. This is live. We have the servers running on the Raspberry Pis, and we're showing the results of those now. We have different intervals that we're updating. I have mine set about every 15 seconds. It's logging about every second. It's actually capturing all of that, but the remote node concentrator is storing it, and it's only shipping about 4 times a minute up to store those in the server. Jose's is about 10 times a minute, right? About every 6 seconds?
Sure. One thing with this is you don't need to have the temperature stored every 6 seconds. That's crazy. You don't need that, for sure. But as we were coming into the demo, we said, okay, you need things moving fast. You cannot get into the room and get everything updated every 5 minutes, which should be the right period of time to do storing at home. So just as a test, because we try to test everything we do, and we try to push everything to the limit. Just as a test, I started my database around a month ago, and actually it's around 400,000 records already. So this is all in the Raspberry Pi. It's taking data every 6 seconds just to push the limit, not to do it like you do at home to have records every minute or every 3 minutes or every 5 minutes.
We're running kind of close on time, so we're going to start. Oh, thank goodness. Thank goodness. Okay. We are going to pick it up a little bit, though, because we want to make sure there's some time to exchange here at the end. So what you see here is a live feed video of Jose's install at home. So that is live on the right. On the left-hand side, that's just a picture of my camera Pi.
This is my Raspberry Pi with a cam, which is like this. This is also an expensive cam, but it's 5 megabytes resolution, so it's really good.
Very good
resolution.
Quality.
But we have to downsize it a little bit to get the streaming, because you have to upload from your router with your router connection, and you have to upload every second an image. So it's actually quite downsized. And actually, I will try to start the lamp here.
Oh, okay.
Let's check if it works, because sometimes it doesn't work. If you are trying to do it on a demo, surely surely it doesn't work.
Yeah, 10 times in a row before you go live, but
Okay, now it doesn't want to. Yes, go ahead.
Well, we have more goodies, more demos.
We'll try with yours. This is again mine case. So this is JavaScript. So we also play with the client side a little bit, and we make this. No, don't do it with this.
No.
Sorry. Sorry. This is JavaScript, so you can run it in any browser, in any mobile, because it's just a web page. So you can browse it whatever you want, whenever you want. And we also did this JavaFX client here, which is, we are looking at, let's see, okay, this is the Pi server at St. Louis, US. So this is actually getting data from the WebSockets stream. And this is the values, and maybe if the cam also wants to come into the demo, it will eventually. Okay, here it is. So it's 4 o'clock.
Yes, we're about, almost 5 now. We're about 7 hours behind where I live, so it's still pretty dark outside, and you're seeing the status lamp, the green LED. One thing I wanted to give a shout out on, if you notice these excellent gauges, I don't know how many of you follow Han Solo on Twitter, Garrett Grunwald, but he is an absolute master of JavaFX custom controls, and we really appreciate him throwing the gauges out there for us to borrow. They really help you visualize the data really well. So now I'm going to play with this a little bit, because we have the full controls running here on the phone. So I'm going to override and see what mischief we can cause here. And again, what I have set up is about every 15 seconds. That's more than sufficient for my needs. I bumped it up to 15 seconds again, so we don't have to stand here for 5 minutes and wait for the next signal to be read. But hopefully pretty soon we'll actually see that light come on. If I haven't angered the demo gods at some point.
You can do it here if you want.
No, that's all right. Give it a moment.
No, but it's not changing.
Yeah, I'm not...
Let's do it here.
Okay, well, while we're waiting on that to come up, again, you see temperature and humidity, you see the voltage level on the battery array, and then you see the current. What I'm actually measuring there is not the overall system for this.
Yeah. Yes, it does.
Right. It's not the overall system for this. It's actually the powered subsystem there. So it's drawing right now about 154 milliamps. That's when the heat lamp is on. If I kick that off, but the status lamp stays on, it'll be about 65. And then when I kick off the status lamp, it goes down to about 55. It's a little bit of a delay sometimes between the visuals, the camera, and the readouts. Yeah, but you can see near real time what's going on there, which is kind of nice. And again, wreak havoc on his and him on mine. And I'll switch that back. Give it just a moment to reset.
You know, everything works before the session, or after the session even better. But during the session, it's not the way.
Oh, it'll work. It just sometimes it's not quite as fast again due to the delays. But
we have the chance here to blame the Wi-Fi connection, but we don't, because it's really reliable for now. So something in between.
Oh, there we go.
Okay, we can try later there.
All right, we'll come back.
We will see here everything on the
And there
gauges.
it went.
Yeah, okay.
Of course. All you had to do is move off.
Yes.
Now we're at 65 milliamps, so if you come back, then you'll just see the status lamp.
Yes, should be,
Once
but
it refreshes. Yeah.
never mind. We will show here that we can get also to the data there. So just check with RESTful web services and go ask to the server, give me the data, and eventually, if it wants, he will deploy here a chart with, it should be deploying a chart with all the values. So maybe we can speak, we have,
we're wrapping
okay,
up.
here it is, thank God. It's
Okay.
here.
So go ahead and-
we're just going to finish because we have 40 seconds. And
Cut the last slide.
yes, we would like to thank you and ask you if you have any questions we would like to answer. So
Any
we can.
questions, ideas, information?
Why don't you go with Glassfish 4 on a Raspberry Pi rather than something like Jetty 9, which is also a JSR 356?
Well, I wanted to get started with Java EE7 just as soon as I could, and Glassfish 4 is the reference implementation. So I grabbed it, again, not expecting a whole lot, but I wanted to see how usable/unusable it would be, and it turned out to be really solid, really performant. I'm not saying that there isn't a better solution out there, but it's worked really well for us so far. So there wasn't a compelling reason to change it, I guess, at this point. Somebody else over here? Yeah.
Do you have any other scenarios, any other projects going on?
Nothing official. I mean, we're constantly trying to press against the edges and see what we can do with this, as probably a lot of you are too. So sometimes you try things and they don't work, and you kind of scrap those, but you take those lessons learned and apply them to a different area. But no, we don't have anything official that's ramping up and going. And I even mentioned at the beginning, or Jose mentioned, I work for Oracle. I'm not giving an official line on this. I mean, this is just something that we've been seeing how far we can take it. So it's kind of a pet project to see where this is going, because it is, again, it's a young area that's growing, and a lot is happening. So you just have to kind of grab and apply what you can where you can. So anything else really quickly? Otherwise, thanks for coming. Please follow us on Twitter. We'll follow you. We want to exchange information. We're all learning. We're all growing. And the more we all know, the better we all get. So thanks.